Can you hear me, guys?
Yes.
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 Okay.
Miss,
Yes,
Miss, why you take me out of the session?
because I had another session, dear. You entered the session really early. You finished the previous one early too?
Yes.
Yes. So when you enter the session, you're actually interrupting the people who are already teaching them. I had 6B. You can ask Ruqayya. Her brother was in there.
Yeah.
So when you enter, you're interrupting the people who are already in the session. So I have to get you out because they keep thinking that why are other people getting into my session? Okay. Give me 1 second,
I
guys.
entered at 11:50. I entered at 11:55 because I knew there was a session before our session, so I had to wait.
All right. I just need the second, guys. Okay.
Okay. Okay.
Okay.
Miss.
Hamza, the miss said she needed the second.
Yes. Okay. I'm back here, guys. We are going to take the attendance now, and then we're going to start right away by correcting the big homework, the homework that was 6 or 7 pages.
7.
All right. We're going to do it together. So first, I'm going to take the attendance. Abdul Halim. Mute your mics, guys. Everyone, mute your mics, please. Mute your mics, all of you. Adam, please mute your mic. Yes, Abdul Halim.
Miss Abdul Halim is here, but he just has a problem with his mic.
I heard him. It's fine. Adham is here. Ahmed Ahmed is here, right?
Yeah.
Okay. Ahmed Hatem is not here. Okay. Ali is here. Amr Hatem is not here. Hamza.
Yes.
Julie. Julie, she's not here. Judy. Okay. Lina.
Here.
Mira.
Here.
Nancy. Nancy.
She's there.
I know, but why aren't she answering me? Nancy. Okay, Ruqayya is
Yes,
here.
Miss, can you hear me?
Yes, I can hear you, dear. Salim.
I'm here.
Okay, and Yusuf Sagid. He's not here. All right, I need you guys to open your books, please. Page 30. Let's start correcting the homework together. Page 30. Yes. And I know that some of you got a little bit confused during some of the questions or answering some of those questions, but we're going to do it together right now. All right. So let's start. Okay. Can you raise your voice because I cannot hear what you just said?
You said you would say who submitted yesterday.
What?
You said yesterday you would say who submitted.
Yeah, okay, yes. All right. I will say right now who submitted the homework. The people who submitted the homework are I will show you right now actually. Yes, the ones that I received their homework. Let's check. Your homework, the big homework, yes. This is it. All right. Yeah. So the people who submitted their homework are Julie, Ali, Mira, Selim, Ahmed Hatem, Ruqayya, Judy, Yusuf Sajid, Lina Hatem, Adham, and Ahmed Ahmed. Those are the people who I received their homework. Okay. Let me refresh also to just make sure that everyone that I said their names. So I'm going to say the names again. Julie, Ali, Mira, Selim, Ahmed Hatem, Ruqayya, Judy, Yusuf, Lina, Adham, Ahmed Ahmed, and Abdul Halim, too. Yes. Okay. So those are the people who submitted their homework, and those are the people who are going to take the mark. If you did not submit the homework, please do. If you did not hear your name. All right, is it clear for everyone?
Okay.
Okay, now let's start answering the homework. We're going to correct the homework. Just 1 second, guys.
This is page this is page what in the homework?
30.
All right, let's start, guys. The first page is talking about boats. And we have a boy called Mike who made 2 boats and he was floating them. What?
You're talking about, oh, hold on. I thought it's page 30.
Yeah, okay, mute your mic, thank you. All right, so he made 2 boats and he brought a bowl of water and he put the 2 boats together next to each other. All right, he left one boat to float freely and the other boat he pushed the boat down with his finger. Okay, do you remember the video, guys, that I made as an activity from my house?
Yes.
Yes, do you remember when I brought a bowl of water and I added a small plate on it and I kept pushing it and the water kept pushing it back? Do you remember this activity?
Yes. Yes.
Yes.
No,
All
it
right.
was pushing it up.
Yes, it was pushing up. Very good. So my question here, what Mike is going to feel once he starts to push the boat? Is that what we call water resistance or upthrust force? Raise your hand if you know the answer. Is it the water resistance or the upthrust force? Yes, Ruqayya?
The upthrust force.
Very good, excellent. So I want you to answer this one, Ruqayya. What should I take? Tick one box to show what Mike can feel as he pushes down.
The force from the water pushing the boat up.
Very good, excellent. The force from the water pushing the boat up. Very good, excellent. Okay, now the next question. The next question is question B. The next question is question B. Mike,
Miss,
Mike?
which page?
this is page 30.
Page 30.
Page 30. Okay, Mike makes masts for the boats with straws. What is the meaning of mast? This is a mast. The mast is it's like a rod or a very large pipe that is added to real boats in order to put the sail on it. Okay, it's a very long rod or a very long pipe that you can fix the sail. The sail is this one. Do you know what's the meaning of a sail?
Yes.
This is the sail, okay?
Yes.
So the mast is what we fix the sail on, all right? So he used straws in order to represent the mast. He used the straws from his house in order to represent the mast. Now, how did he attach the mast or the straw to the boats? He used modeling clay. Modeling clay is the Play-Doh, okay? He brought modeling clay and he fixed the straw in the boat using the modeling clay. Now, Judy, my question to you is, the modeling clay sizes, are they equal, or is there one bigger than the other?
There is one bigger than the other.
Which one is bigger than the other?
Both two is bigger than the other.
Yes, the modeling clay that he that he used in boat 2 is bigger than boat 1. Very good. Now I want you to answer the question, please, Judy. Explain why boat 2 floats lower in the water than boat 1.
Because Mike put more clay in boat two.
The what?
Because Mike put more clay in boat two.
Very good. So this makes boat 2 heavier, right?
Mm.
Yes. So because the modeling clay in boat 2 is heavier than that in boat 1. Okay, I'm going to write the answer right now.
Miss,
Yes.
I said because the modeling clay is more than boat 1.
What does that mean?
Like the clay is
Yes, you have to specify which modeling clay. When you say the modeling clay is bigger than boat 1, which modeling clay? Are you talking about the modeling clay in boat 1? Or are you talking about modeling clay in boat 2? So you have to specify, okay? The modeling clay in boat 2 is heavier than that in boat 1.
Miss, I wrote because boat 2 has more modeling clay than boat 1.
All right, very good. But you can add, and this makes it heavier. Okay?
Okay.
Thank you, Ruqay. All right, guys. Now let's move to page 31. Should I erase this and skip to the next page? Okay.
Yes.
All right. So let's move on to the next page. The next page is page 31. Page 31. Mike makes sails for the boats out of paper. He uses a straw to blow one of the boats along. Draw an arrow on the picture to show the direction of the force pushing the boat along. This is an easy one. So right here, Mike made this boat, this complete boat, the boat with the mast and the sail in it. And then he brought a straw and started to blow from one side of the boat to make the boat move. Now they want to know what is the direction of the blowing and what is the direction of the moving of the boat. Yes, Lena, are you there? Lena?
What?
What?
Yes.
Is that the way you answer the teacher? You say what?
I didn't say what I said. Yes.
No, you said what? Anyway, what will be the direction of the blowing and what will be the direction of the moving of the boat? Is it going to move to the left or to the right?
The left.
Yes, the left, because he's blowing and the air that comes from his blow is going to move the boat to the left. So this is what you're going to do. Thank you, Lina. You're going to draw an arrow which shows us what will be the direction of the force pushing the boat along. Now I want to ask you a question, guys, and a smart one will answer this one. What is the force in this case from the forces that we have learned? What will be the force that will make the boat move? Let me give you some choices. Is it water resistance? Is it air resistance? Is it gravity? Huh? Who can answer this one? What will make the boat move? Move. Huh? Yes, Mira.
It's water resistance.
It will make the boat move. Then why is he blowing?
Friction.
What? No.
Miss,
Think.
can I say it?
Please think before you say any answer.
Miss, can I say it? Miss, can I say it?
Give me 1 second, dear. Give me 1 second. Okay. Now he is blowing. He's blowing air. Air resistance, exactly. Air resistance. This is the opposite of the parachute example, guys. In the parachute example, we said that the air resistance causes the parachute to land slower, right? Correct?
Yes.
Yes, but in the case of boats, air resistance actually help the boat to move faster.
Miss, I
Miss,
said
I made it water resistant.
No, I'm asking you a separate question. This is not a question that is related to the questions in the book. This is a question that I am asking you guys. Okay? Yeah, okay. Now I need you just to forget about the book for 1 second. I need you to understand the concept. All right? The first thing is that we talked about the parachute. And since the parachute is landing from up to down, so the air resistance, is slowing it down. But if we are talking about boats, and this makes more sense because boats are supposed to be moving by the effect of the air. So air resistance actually is helping the boat to move faster. Okay. So in both cases, whether it's the parachute example or the boat example, both of them are affected by the air resistance, but the effect is different. In the parachute will land slower, but in the ships, it will move faster. Do you understand? Huh?
Yes, I understand.
Do you get it?
Yes. Yes.
Yes, because here the air
Yes.
resistance is pushing the boat. So it will make the boat move faster. Okay? All right. I just need to plug my charger because it's going to close right now. So give me 1 second, guys, please.
Okay.
All right, I'm back. So now let's do the next question. Okay, the next question says, what is the name of the force that slows down the boat? This is opposite to what I just said. I told you that the air resistance will make it move faster. But what will make the force, what force will make it slow down? Huh? Hamza. Hamza?
Yes, Miss.
Yes. So I said that air resistance, because the boy is
Will
blowing, the boy is
Will
blowing,
move faster.
will make it move faster, exactly. But what is the force that will make the boat move slower or slow down the force? The boat?
The water resistance.
Excellent, the water resistance, very good. Water resistance. So air resistance, the boy is blowing to push the boat and make it move faster. Meanwhile, since the boat is floating on water, water is trying to push it back. And this is why water resistance is the force that slows the boat down. Do you understand, guys? Do you get it?
Yeah.
Is there anyone still confused?
No.
All right. Now let's move to the next question. The next question, Mike blows the boat when it has a big sail. All right. Mike blows the boat when it has a big sail. Then he puts a small sail on the boat and blows with the same force. The question is, first he finds out that the big sail makes the boat go faster. I think we covered this area when we were explaining it in the picture right now. Let me say it again. Mike blows the boat when it has a big sail. Now he puts a small sail. He finds that when the boat had a big sail, it was moving faster. Explain why the bigger sail makes the boat go faster. Write about the forces on the sail in your answer. So first you have to tell me what is the name of the force again that is affecting the speed of the boat, the one that makes the boat move. What is its name, and why did the bigger sail make the boat move faster? Yes, Ali.
It's the air resistance because the air resistance is getting a lot of air on the sail, which means the sail will just stretch out and it will make it go a lot faster. It will make it go a lot faster. But the
Excellent.
small sail won't stretch out too much, so it won't go as fast as the big sail.
All right. So the big sail have a bigger area, right? It has a bigger area. So the air will be pushing it more, correct? Yes. And what is the name of this force?
Air resistance.
Air resistance. So first of all, we're going to write the name of the force, because right here, they asked us to write about the forces on the sail in your answer. So the force which affects the sail is air resistance. Very good. Now, why is the bigger boat or the bigger sail make the boat move faster? Because the big sail have more area, which will make the air push it more.
Miss, you wrote froze. Miss, you wrote froze, not force.
Oh, sorry, force. Okay, is it clear, guys? Do you understand?
Yeah.
Yes.
Yeah.
This I wrote because the resistance will be easier for it because the big sail has more area.
Okay, yes, this is also correct.
And Miss, I wrote because the big sail is affected by more air resistance the way the boat is moving.
Again, Adham, please.
I wrote because the big sail is affected by more air resistance the way the boat is moving.
Yes, it is affected by more air resistance. Yes, you can just add that because it has more area. Okay, you just can add that this is because the big sail has more area.
Miss, will we open page 32?
32, yes. Did you finish answering this? Should I'm waiting for the people who are copying.
I
Did you
wrote
finish?
that the big sail has more area, so the air will. I wrote that the big sail has more area, so that means the wind will push it more and the boat will go faster.
Page
Okay.
32 is so easy.
Oh, yes. Now let's go to
Incredibly easy.
page
It took
32.
me 3 seconds to solve it. I just needed to read the questions, and it took me just 3 seconds.
Okay, very good.
Like ABC.
Okay. Measuring forces. Lizzie uses a force meter. By the way, guys, next week I will show you, once I get to school, I will show you a real force meter to show you how it works, okay? So because the school just got a new one, so I want to show it to you. Measuring forces, Lizzie uses a force meter. And we know that the force meter measures what? Does it measure weight or does it measure weight or mass?
Wait.
Yes, it measures anything related to force. And since weight is related to force, so it measures weight. Okay, she measures the force needed to start a brick moving on different surfaces. So right here you have a brick, okay? And what does she do? She attaches the brick to the force meter, okay? And when she does, she starts to pull the brick. Once the brick starts to move, she sees what is the reading, and this is how she knows how much force did she exert or did she perform in order to make the brick move. Now, where is the trick? The trick is in the surfaces. She's not doing this in only one surface. She's trying this in 4 different surfaces, A, B, C, and D, okay? And those different surfaces could be, for example, A is tile, maybe B is sandpaper. She's trying different surfaces to pull the brick on different surfaces, okay? Now let's see what were the forces that she exerted in each of those surfaces. In surface A, it took her 19 newtons for the brick to start to move. In surface B, it took her 30 newtons. C, 16 newtons. D, 6 newtons only. Okay? Yes, Judy, you may go to the bathroom. Ahmed Ahmed, I want you to answer this question, please. They want you to arrange the surfaces from the easiest surface that the brick will move on to the hardest surface.
First one is D.
The first one is D. Yes, very good.
Then C.
Then C. Yes.
Then A.
Then A.
Then B.
Then B. Very
Miss,
good, Ahmed.
9.
What?
There was a participant.
Ira was 9, but then she changed her name again.
What happened? I don't understand. What happened? Someone changed their name?
To 9, then they changed it back again.
Okay. All right. I need you to open now page 33. So far, guys, is there anything confusing? Is there anything that you don't understand?
No.
Please tell me now so that I can help you right away.
No.
Don't wait until the revision week. I want you to tell me if you have any problems that I can help you with right now. Okay. All right, let's go to page 33. In page 33, Lizzie uses the force meter to pull the brick on a tabletop. She spreads a spoonful of oil on the tabletop. She puts the brick on the oil. Adham, I want you to answer this question, please.
The brick will move more easy.
The brick will move more easy. Thank you so much. Excellent. So the brick moves more easily. This is the right answer. All right. Let's move to the next question. Question C. The diagram below shows 3 forces acting on the brick as it is pulled on each surface. Okay, so we have here, this is the brick, and there is the force A is the gravity, which is trying to pull the brick down. Force C is the force of motion, the pulling force or the force from the hand. And we are left with force B. What is the force, the name of the force that works in the opposite direction of the moving force? What is the name? Yes, Ruqayya.
I wrote it pulling.
No, honey. This is pulling. See the force of the hand. She is trying to pull, or she, okay? She is pulling. This is force C. So this is the direction of the motion. C is the pulling or the direction of the motion. What is the force that is working in the opposite direction, Ruqayya?
Pushing.
No, honey. If you're moving somewhere, what is trying to pull you back? We talked about this a lot of times.
What is it again?
When you're moving, there is something moving. What is trying to stop this thing from moving?
Friction.
Friction, exactly. Please, the rest of you, mute your mics. Mute your mics so when someone is answering, I can hear her or him. Friction, excellent, Ruqayya, this is the answer. Okay, so force B is the friction force. How did I know? Since C is the force of motion, right there they wrote force from the hand. Force from the hand, it means that this is the force that makes the brick moves. Okay, so what is always trying to stop any object from moving? Friction force. Okay, and this is why it's always in the opposite direction of the motion. If the brick is moving this way, the friction will be working in the other way. Okay, so this will make force B friction force. All right. Okay. Is it clear for everyone?
Yeah.
The rest of you guys, do you understand?
Yeah.
Okay. Okay, let's move to the next page, page 34.
Miss, can I answer?
Oh, yes, Mir. Okay, page 34. These scales measure in newtons. They work because the spring inside is compressed when an object is placed in the pan. Okay, now the question says the Newton is the unit used to measure what?
Wait.
Weight. Excellent. Weight. And if you wrote force, it will also be correct. Okay, so Newton. All right, the Newton is the unit used to measure weight. Okay, page 35.
Can I answer?
Yes, Judy, you may. Kerry and Jason adjust the scales to 0 before weighing an object. What is the weight of the object in this picture? So let's look at the picture again, Judy. Huh? What is the weight here?
40 Newton.
Yes,
40
40 newtons. Very good. So the answer is 40 newtons. 40 newtons. All right. Next, Jason, this question may confuse some of you. This question, although it is answered in the question itself in the beginning of page 34. Okay, the question says Jason pushes down on the scale. The pan pushes up on his hand. What is causing the pan to push up on his hand? What do you
This
think?
someone,
It's so easy. It's so
this
easy.
is someone
Is what?
or screaming or talking. It's a voice of a baby.
Of a baby. Okay. I don't hear it. All right. What is causing the pan to push up on his hand? There is something inside this balance that pushes up against his hand. Let me draw this thing for you. What happened? All right.
Miss, do I answer it too or someone else?
No, someone else will answer it. I'll just draw what is inside this scale for you guys. Do you know what's the name of this thing? Yes, Nancy.
Zigzag.
Nancy. Nancy.
Miss, can you hear me now?
Yes, I can hear you now, dear. Tell me what is the name of this thing? It is already written in the beginning of the question in page 34. They work because the what inside is compressed. Look at page 34, Nancy.
Okay.
At the beginning, they work.
Miss, I think I know it.
Right above the picture. They work because the what inside is compressed.
Compressed when an object.
No, I don't want you to read. Tell me what is compressed inside the balance. Read the beginning. They work because the what inside is compressed. What is inside is compressed?
The spring.
The spring. This is what is the spring. This is what the spring is. Okay? So what is causing the pan to push up on his hand? Hamza, can you tell me?
Yes.
Yes. So
It's-
what? No, Mira, it's not the upthrust force. The first one.
Miss.
The first one you said is correct. Yes, Hamza.
It's the spring.
Yes. The spring is compressed inside the balance, and this is why it is pushing up on his hand.
Yes.
Yes. So the compressed spring is the one that is trying to push back against his hand.
Miss, I wrote it a spring force. The spring force.
The spring force?
Yes.